my presentation will be, let's say, about a small part of the work that we have carried out in scope of the UNESCO chair, and also the chair of hydrology and hydraulic engineering at the University of Ljubljana. The main author, or let's say inventor, promoter of the idea more room for water is Professor Brilli, who is unfortunately not able to be with us today, so I'm the one who will present this initiative. Just a quick overview of the presentation. The main talk will be about problems with floods, damage with floods, but this is just a small part of the whole water management issue that the More Room for Water initiative is trying to tackle. So we will just briefly look into some, let's say, main problems that we are dealing with floods in Slovenia. Then we will look into a little bit more in detail into this More Room for Water initiative. And we will look into some possibilities to implement these ideas of More Room for Water initiative into, let's say, engineering practices or some innovative attempts to manage or to improve the river engineering methods. And at the end, we will look into some, let's say, attempts to restore some sections of streams in Slovenia and what are the, let's say, final results of these attempts. So just maybe a few numbers about the damage in Slovenia. They are taken from official data by the Ministry of Environment and Spatial Planning. So in the last 24 years, we have approximately 2 billion euros damage due to floods. An estimation is that annually we have in, let's say, last 10 years about 150 million per year. Altogether, the damages related to floods. We had quite a few devastating flood events in Slovenia. Some of them were already presented before. And the fact is that we are detecting, or we are noting, an increased number of flash floods in Slovenia and also the related damages to this flood. So what could be the main damages due to floods in Slovenia? Maybe the same as all over the world. The present results are the present floods are a result of past, let's say, spatial planning. Here you can see a map of Ljubljana, for example. This southwestern part of Ljubljana and southern part of Ljubljana is the most exposed to floods. From the old map from the 18th century, you could see that there was no infrastructure, no urbanization. And if we look at the situation today, you can see here that we have a lot of urbanized areas which are exposed to different sorts of flood hazards and flood risk. So this is probably a very known situation. What could be a little bit more specific for Slovenia is that we know that we have a lot of problems with maintenance of the water infrastructure. Here we have some figures about, for example, one flood event and situation with the river infrastructure, with the river embankments. For example, in year 2009, where we can see some small damages of the river embankments, of the river levees. And then after the flood event, you can see from the pictures below how the whole section of the river was completely eroded, and a lot of, let's say, a lot of sources were invested to, let's say, stabilize this section in the following few years. Another thing that is also problematic for Slovenia, and it's becoming more and more serious, is problem with large woody debris. It's partly a result of the fact that the percentage of the forest in Slovenia has considerably increased in the last, let's say, 30 years. Another thing where the natural disaster events in the last couple of years, for example, a sleet event, ice rain event, as you can see here. And there were also some, let's say, extreme windy events which damaged the vegetation. And this considerably reduces, for example, the hydraulic conductivity of some river sections, especially the sections where this vegetation stacks at, for example, breach openings or culvert openings, as you can see situation here from these two pictures from two flood events in Slovenia in last decade, for example. So what is the idea behind the More Room for Water initiative? Like I mentioned, a little more stress will be on floods, on flood damage, but the idea is not just reduction of flood damage and, let's say, tackle the floods. The main aim of the initiative is to somehow gather a knowledge database that will enable a scientific assessment and promotion of integrated and holistic sustainable water management and also space management. We are currently trying to analyze some current states of the water management in, of course, in Slovenia and in different European countries, and we try to pose some future direction for the development of this river management, especially by identifying some good and bad practices, as we could see today through some other presentations. So basically, More Room for Water is not directed only into floods, but means much more. So we are trying to cover all a very wide range of water management issue or river engineering issue. Here you can see some examples of how to assure, for example, more room for groundwater, which means how to maybe in some areas raise the levels of groundwater, or how to improve the water storage, how to manage the excessive volumes of water in urbanized areas, which is, of course, also a very crucial problem. If we look at one example also from Slovenia, it's a small catchment that was mentioned in one presentation before. So again, you can see this small stream catchment area in an old map. So these lowland areas, which are now, of course, urbanized, were in the past belonging to river. These were the once flood areas. And of course, the solution for the flood problematics in this area was construction of a dry detention area, which has been finished, I think, a few months ago. And basically, if we think more in this idea of more room for water, we have assured more room for water inside of this dry detention area by implementing this measure. Another thing that is worth noting in scope of this initiative is use of bioengineering methods for stabilization of stream channels, which is widely promoted, but has, together with the implementation of these methods, we have also a lot of problems that I will talk about a little bit later. Maybe one example of good, let's say, good case study example is one example where a combination of this more classic water engineering works by using more, let's say, traditional materials like stones and concrete was combined with live materials, for example, willow stakes. And here you can see, after 30 years after implementation, how the stream banks look like. So the vegetation has overgrown the stream banks. So this is one, of course, also a possibility to improve the state of the ecological state of the rivers according to, for example, Water Framework Directive. We are mostly talking, of course, about the floods, but there is also the other extreme, the low flows, which are very also very problematic in terms of ecological state and also chemical states of streams. And I have a few examples how the ecological state of stream was improved by, in principle, very simple engineering methods. So there were some, for example, stone weirs installed in a stream nearby Ljubljana, in this urbanized area. And by installing these streams, we achieved a huge increase in the water volume during the low flows, for example. The water volume here in this case almost more than doubled. And this influenced, for example, the population of fish, which was during the regulation of this stream completely devastated. Another interesting picture or another interesting thing can be also seen from these three pictures. On the left side we have a natural channel where you can see a lot of these hydrogeological elements in the stream, the pools, the riffles, very variable water velocities. And on the right you can see one channelized channel in Ljubljana. But the interesting thing is that discharge in these two both streams is the same. But the water volume in this natural stream is, of course, much higher. So in the sense of assuring more room for water, we can do that also for the low flows, not just thinking about the extreme or flood events. Another thing that I would like to point out is also the aspect of hydraulic conveyance. So we have done a lot of experimental measurements, like was shown by my predecessor in several experimental catchments in Slovenia. And for example, here are some measurements inside of the urbanized, let's say, heavily regulated, devastated channel, which is paved in concrete. But actually, even though the channel is paved, we, during the measurement, we observed quite different hydraulic conditions in different seasons. For example, in summer, the water velocities were more than or approximately 30% lower there than in winter. So even though the material is basically artificial, there are nevertheless some differences in the velocity field, for example, in this channel. Another example of, let's say, some experiment with the river restoration in Slovenia is again a small stream, Želimerščica stream, which is also positioned near Ljubljana. This stream was in the past regulated to enable the agricultural production nearby. Okay. And following these regulations, the Fish Angling Society decided that as a result of this river regulation, the river channel as a habitat was pretty much devastated. So they installed some small weirs in the stream channel. They replanted some of the riparian vegetation, and they tried to, let's say, improve the condition for the fish and for the overall water habitat. But the interesting result after the 30 years of, let's say, no intervention from the man, so the river took its, let's say, natural succession in this period, and we can see that this channel became completely overgrown by the riparian vegetation, and in hydraulic terms, it is very problematic, for example, from in view of floods, because the hydraulic conductivity of this existing channel, as you can see here, which is completely overgrown by the vegetation, has considerably decreased for, let's say, more than 75%. Only 1/3 of the discharge can now be conveyed at the bankful discharge compared to the, let's say, the channel that was constructed in the 70s. And related to this vegetation processes, also the intensive processes of sedimentation in this ridge also occurred. And all this together, of course, poses a huge problem for future flood situation or flood hazard situation in this area. So to draw some conclusions, so as you can see, the main result of the past river management is actually that we took some space or some room that once belonged to the water. This is, let's say, one of the main results of the past river regulations. And this also influenced the sediment transport and also the hydraulic conditions in this river section, which were regulated. And the one thing that also stimulated us in scope of the UNESCO chair to think about assuring more room for water is the fact that when we talk about river restoration or rehabilitation project, we cannot think about them without thinking how to assure additional place where this river restoration project could be implemented. So the main challenge that one of the main challenges that we see is related to identification of areas where this room could be provided. For example, for safely diverting the flood waters and improving the flood hazard and flood risk situation in urbanized or other areas. And this is also related to the statement that we have contributed to the Ljubljana Declaration. Okay, thank you for your attention.
Thank you.